Welcome to Inspiring Minds, powered by the Edison Awards, showcasing the leading innovators from across the globe. I'm your host, Jennifer Trammell. Imagine a world where we can eliminate methane gas emissions that contribute to rising temperatures across the globe. And we can do that using a generator that works 24/7.
The potential impact just in the US, just for us, in the next 5 years is equivalent to about, let's say, 5 million cars.
And it's all based on a concept developed 200 years ago, the Stirling Engine. Qnergy's innovation, the PowerGen CAP3Nano system, eliminates methane emissions from off-grid natural gas well pads. The engine is designed to capture raw, unprocessed methane that would otherwise be vented or flared and convert it into useful electricity and heat. The engine is coupled with a compressed air system, and it creates a solution that substitutes methane with air. The manufacturing results in a product that requires no scheduled maintenance for up to 8 years. That's even in the harshest, most remote environments. Pretty amazing, huh? Qnergy CEO Ory Zik is with us today to talk about the impact. Ory Zik, welcome to Inspiring Minds.
Thank you. It's a pleasure to be here.
Well, we are so glad to have you here today. Congratulations to you and the team on your Edison Award.
Thank you.
Now, I'm especially excited to talk with you because you like to tackle the big problems, and we're talking climate change. So I'm hoping that you can lay out the problem from your perspective so that we can better understand the solution Qnergy has brought to the table.
Sure. So when we think about climate change, we often think about carbon dioxide as the gas that we need to abate. But about 25, maybe even more, maybe some people claim 50% of the global warming is coming from another gas called methane. Now, carbon dioxide is very hard to abate, and we've tried during the pandemics. It's very hard to abate because our economy actually runs on things that emit carbon dioxide, transportation, etc. And there's a lot of very important progress in renewable energy and alternative transportation, etc., to abate it. But if we focus on methane, methane is relatively short-lived in the atmosphere. So whatever we abate has an impact. And methane also on a per weight basis, namely a pound of methane, is about 80% more harmful to the climate than a pound of CO2. And on top of that, methane is actually a fuel. Natural gas is mostly methane. So if we can convert otherwise emitted methane to useful energy, there's multiple reasons to do it because we gain on multiple fronts. Now the challenge, and many people are doing it, and many people are thinking about methane, and in the latest reports on climate change, methane was forefront. The one thing that people ignore is that methane is actually a distributed problem. It's not a centralized problem. It's a distributed problem that needs a distributed solution. Most of the methane sources are actually small dairy farms, small landfills, natural gas sites that are scattered all over the country. So they are decentralized. But most of the solutions that we currently have are centralized, like renewable natural gas that applies to dairy farms with more than 10,000 cows, waste to energy facilities that apply to huge landfills. So what Qnergy does is looking at this as the methane problem as a distributed problem and trying to address this 75% of the problem with a solution that turns otherwise wasted methane into useful energy.
Excellent. So let's talk about that solution. And what particularly interested me is the technology really goes back 2 centuries.
Yeah, the technology is a fascinating story that happens across 2 centuries and 3 continents, if you will. So the original invention of the Stirling engines the patent was filed in 1816 by a Scottish clergyman called Robert Stirling. And since then, there were a lot of scientists and a lot of innovators and entrepreneurs that tried to bring Stirling engines into the market. None of them ever built a commercial Stirling generator. There are multiple reasons to it. One key reason technically is that the original Stirling engine still had a rotating part, still had like some kind of a wheel. If you want like a mind image for it, think about those trains that you see in Western movies, that at the end you have like a linear motion translated to a rotational motion. And that's actually always a source for high maintenance. So part of the reliability advantages disappeared when you have that. You have friction, you need lubrication. So that's part of the advantage that goes away. During the 60s, a guy named Professor Bills at Ohio State University invented the linear Stirling engine, what he called the free piston Stirling engine. So it's all linear and doesn't have any rotating parts. It's suspended on springs. So that's part of what was needed. The other part became only commercial during the probably early 2000s in a low-cost way, which is power electronics. The electronics that allows you to convert AC to DC and make it in an efficient and economical way. What we see today in every solar panel was pretty expensive during the 80s and maybe early 90s. And on top of that, now you have a low-cost precision manufacturing. We can buy a robot that can weld for hundreds of thousands of dollars, something that was totally unavailable a few decades ago. So when you take this modern innovation and plug it into this old idea of a Stirling engine, you get what Qnergy is bringing to the market.
Okay, so we're starting to see how those innovations build on each other, leading to the Qnergy team's own innovation. Help us understand more about how exactly this works.
The Stirling engine has two unique advantages, but still one disadvantage that is important to point out. One unique advantage is the reliability. It's very reliable. The engine is nearly maintenance free. The easiest way to think about it, the engine looks very similar to a welded scuba tank. It's like a closed enclosure. So once you weld it seal, very little things can happen to it. So it can live for decades in the field and produce energy. That is because it is unlike the internal combustion engine, it's external. All the heat is external to the engine. So none of the pollutants or the gases that will lead to corrosion enters the engine. The other advantage is that it can operate on very dirty, unrefined methane, because again, this methane doesn't get into the engine. If you will use on your car the kind of fuels that we use on our engines, you will need very, very frequent maintenance to clean it up. The disadvantage is that it's pretty expensive out of the gate because we're building now thousands per year, but not the millions that the engine industry is building. So, and we're the only ones. So from these advantages and disadvantages, you can derive a business strategy. And the business strategy is to address the distributed methane, starting with natural gas companies like oil majors that are really interested in abating their methane emissions and can afford it. And as we work with this industry, the natural gas industry, our volumes go up, our costs go down, and that allows us to address other industries like landfills. And as our costs go down, we can go to dairy farms. So there's a little bit of a linear motion here. We don't do everything at once. First, because we try to be focused, but second, because of this cost path.
So as you build those economies of scale, hopefully you'll be able to reduce those costs and get this into more places where methane is being produced. What will be the impact of that if you can grow the scale of what Qnergy is doing? What could we see in the future?
So if you look on the methane that is abated by the oil and gas industry today in the US, it's equivalent to the emissions of about 5, maybe even 10 million cars. And that's something that we're already active on. We've published about a year ago that we've abated the emissions of the town in Utah where our factory is based. because it's a town that has about 100,000 people, and we've abated the equivalent of about 100,000 cars. The potential impact just in the US, just for us in the next 5 years, is equivalent to about, let's say, 5 million cars. And then as we go internationally and go to other industries, this will grow.
Well, let's talk about innovation. Innovation, of course, is at the heart of the Edison Awards and critical to Qnergy. We know innovation is not always linear, doesn't always go smoothly. Tell us about the process for you in this creation.
In terms of our innovation philosophy, we are also decentralized in innovation, not only in our application. We bring experts based on their expertise from all over the world. Our material scientists sit in Finland, and we have an office at MIT where we hire engineers. We have a PhD physicist that is from France. So we have engineers that came from Israel. We're global in our approach to innovation, and we always try to start with the problem that we try to address. For example, in oil and gas, what we got the award for, traditionally the oil and gas industry is using the pneumatic pressure of the gas that comes out of the ground for controlling the flow of gas on their sites, whether it's separating water from the fuel, whether it's controlling where the fuel will go, whether it's safety. But the end result is that nearly half of their intentional emissions, a quarter of the total emissions, is just pneumatic valves that open and close all the time. And it's a problem of more than 1 million valves in the US that all emit very small amount, but there's 1 million of them. So the solution is to replace natural gas as a source of power with compressed air. And the beauty of this solution is that it's a plug and play. Namely, it's more plumbing than anything else once you have it, because you disconnect a gas pipe and you connect an air pipe. Now the question is, how do you bring an air pipe or compressed air to a site which is remote from everything? Electricity doesn't have any utilities. So that's where the Stirling engines come into play. We place a Stirling engine that takes some of the methane that comes out of the ground, convert it efficiently to electricity. The electricity runs a package of air compressors, and the air compressors provide the air to the site to replace emission of methane as a global warming gas with air that nobody cares about. It has safety advantages and huge environmental and greenhouse gas advantages. The innovation that we got the award for is for a compressor package that is very reliable, because our engine is known for its reliability. There's no issue there, but air compressors tend to fail. So we built a package that has a redundant air compressor package, so they never work together. And if one fails, the other still works, and we have enough time to replace it, because these sites need to be on 24/7.
Yes, innovation definitely is critical for your company, because you're building this as you go along, an entirely new aspect to the industry. Tell us about a time things maybe didn't go according to plan. How did you have to redirect? What did you learn from that?
So first of all, there are many, and innovation cannot be planned. It's a journey, sometimes driven by a serendipity. And sometimes we take a more MacGyver approach, just to try to something small, see if it works, and then build on that. I should say that a lot of the engine technology was developed with NASA funding. And NASA funding tend to not focus on cost, but focus on performance. So we need to keep the performance and reduce the cost. So we needed to ask a lot of questions. And the one thing that we've learned is that you need to be really careful about your assumptions, especially the quantity assumptions, because there's a different manufacturing method. For example, if you want 100,000 of something or just 2,000 of something. And originally we thought about different quantities that forced us to some industrial processes that included stamping and very expensive tooling to produce hundreds of thousands of something that we only need like probably 5,000 of. So we cycled back and went to laser cutting and water cutting and things that are now cheap and automated, reduced cost, after spending a lot of money that we didn't need to spend, and made the process more efficient.
I think that's a good lesson for all of our listeners. Go back to those assumptions that were underlying what's been created so far and say, wait a minute, is that actually applicable to us? And if we change those assumptions, we can change things down the road that allow us to reduce costs, to increase quantity, and really innovate.
Well, the multiple reasons. First of all, people go to work partially because they enjoy the day and partially because the mission is what they believe in. And for me, it's both. Second, every day is different. Every day we solve something different. And then, in addition, I get to work with very passionate, very talented individuals, and that's always a blessing. And our DNA in Qnergy is curiosity. People are curious. They want to learn more. They want to, to find new ways to do things, and that's what I like.
And that passion certainly comes across. That's why we love seeing great teams like this recognized with Edison Awards. What does that award mean to you and the team?
So for us, we nearly don't do any marketing. Our business strategy is to work with the customer, prove to them that our product performs better than anything that they could have expected, and then work deeper and deeper with that customer. So as a company that does very little marketing, this award is an external recognition of the innovation, which is very important for the team, and we're grateful and proud of it.
As you should be, definitely. So let's envision 10 years from now. If everything goes according to the vision you have in your head and Qnergy's plan, what does that look like?
So the biggest source of methane, man-made created methane, is organic waste. Humanity, by definition, because we're organic, we create organic waste. So imagine a world in where you have like low-cost Stirling engines at every university, army base, wherever people, homes, residential settings, offices, wherever you create organic waste, you can generate electricity out of it without having to ship it to the landfill or recycle it or struggle to compost it. Just use it as fuel. It's a very valuable fuel if you have the technology. And then if you do that, plus natural gas, plus landfills, plus dairy farms, you reduce a substantial amount of emissions because you need to produce less energy and you emit less methane. We'd love to see this future.
So making electricity that can power our world from waste that we're creating anyway as organic beings.
And if I'm allowed one more thing, think about the 500 million people on the planet that has more access to animal manure than to clean energy. And think about the possibility of giving them energy using the animal manure that they already have and saving all the health and pollution issues.
That's a great vision. Thank you for sharing it with us.
Thank you.
Well, congratulations, Ory Zik, to you and the Qnergy team on this year's Edison Award.
Thank you.
You've been listening to Inspiring Minds, powered by the Edison Awards, where we showcase leading innovators from across the globe. I'm Jennifer Trammell. Thank you for tuning in, and we look forward to having you join us for our next conversation with another inspiring innovator.